Welcome to session 2 of Organizational Opportunities, Stories from the Front Lines. Today we're going to talk about understanding the needs of the internal customer. So the story I want to tell is about a manufacturing company that was a producer of large components that needed to be assembled, and it's an engineer-to-order environment, so there's a lot of engineering work required to make these products. And so when I started working with them, I went out into production and I went to the assembly department, which is the last department that puts all the components together to put these items together for the customer before the customer comes in and does a runoff. And what I found was that a lot of the projects were stalled because they were missing components. And when I asked the assembly guys what they needed, it's like, well, a lot of the components that we need early in the assembly aren't here, but the parts that we have that are needed later in the assembly are here. So there was a missynchronization between what engineering was putting out to production and what assembly needed. And so that missynchronization, what happened was it caused a lot of parts to be sitting, waiting to be worked on and waiting for other components to show up to be assembled on the final assembly. And there was just a lot of extra movement, a lot of extra waste happening, and a lot of disorganization. And so what happens is if we don't understand the internal needs of the customer, we produce stuff in engineering that's easy for us to work on. So what they're working on is stuff that was like, oh, part of this assembly is like something we've already engineered. So let's take that component and let's finish that component engineering and get that out to production. But it wasn't in the sequence that was needed in assembly. So we had this missynchronization. And so if you have an organization that has this type of configuration, we call it a plant configuration, then these are typically the issues that we see as missynchronization. So if I look at generic operating environments, what I found is this matrix here. Most companies fall into this matrix. So we have 4 plant types, which is V, A, T, and I. So if you're familiar with theory of constraints, you know what those plant types are. We have different order types: engineer to order, configure to order, make to order, make to stock. So all companies fall into one of these 16 boxes. And then we have this depth of the box here of mix. So we have low mix to high mix. So there's variability in mix. So the company I'm talking about was a engineer to order A plant. And so when you have missynchronization issues, it's a problem because if I'm putting components together and I have 10 components I need to put together, if I'm missing one, I can't put the assembly together. So an A plant structure, this is what this company was, is having operations in assembly or convergent points. So we have different production operations. There's different components that go through different production operations, and then these have to come together in sub-assemblies, and then the sub-assemblies come into a final assembly. So this is a structure. So if you're this type of structure, you're probably familiar with what I'm talking about with this story. So what it does is we start with many raw materials going through convergent points, ending up with few end products. So that's an A structure, and different parts that are needed for the same assembly are often produced by the same production department. So these machines and these departments are producing all the components that are needed for the final assembly. And again, if we have poor synchronization, then we can't put the products together. So we talk about synchronous flow. We're looking at effectiveness versus efficiency. And of course, our goal is to flow work to the customer demand. In this case, it's our internal customer, which is assembly. We're trying to flow work to their requirements. And what happens is if we have this boat at the top where everyone's synced together and we're syncing to our final assembly, everyone's rowing together, then we get the products and projects done in a more streamlined fashion. But if everyone's working in isolation and trying to be efficient in their department, what happens is the boat goes off course, and then we're missing components that are needed, and the assembly stops, and we're waiting for components to show up. So if we look at a system of push versus pull, so most companies are push. And so what that means is the supplying process is working on whatever they feel is important. They're doing these value-added steps, and they're pushing it to the consuming process, which is the downstream process. And we have work in process. And of course, if the consuming process can't use that, then we have a lot of whips sitting between the value-added activities. What we really want is we want to create this pull. So pull means we start with the consuming process, they're telling the upstream process what they need and what sequence. And what happens is we can reduce the WIP and we can create FIFO lanes, first in, first out, and then the products flow through these lanes to the consuming process in the order and sequence that they need to be most effective. So that's the benefit of a pull system. So when we understand the internal customer needs, we need to synchronize to those needs, which are the downstream operations. So synchronization is about understanding the interaction of the departments within the organization and working to the needs of the downstream departments, which also can be our internal customer. So the hard part for companies is to be most effective, most departments need to be less effective. So they need to be less efficient and working to the needs of the downstream department. And then if we work to the needs of the downstream department, then the organization is more effective. That's our session for today. Hope you enjoyed the session.